Okay, so little recap, right? On Monday we started with the shape of a circle, and we talked about the circumference, and then yesterday we talked about the area of that same shape of a circle. Okay, today we're going to stick with area, but we're going to talk about area of other types of figures. Today we're going to talk about, more specifically, area of composite figures. All right, so this is, we do have vocab, so grab your binders if you haven't already done that. Green on the left, notes on the right. All right, here we go. Our very first word is exactly probably the word that you were wondering about, and that is the phrase composite figure. Everyone? Composite figure. So here's what a composite figure is. It's a figure that is made up of two or more shapes. I should say shapes, and it does. The little figure there is covering up. A figure that's made up of two or more shapes. So what I want you to do is go ahead and draw that composite figure right there. So taking a look at that, right? Composite figure. What two shapes make up that composite figure? Everyone, what are they?
A triangle and a square.
Now be careful with the word square. A lot of us love saying square, but a square has equal sides, all four equal sides, right? Okay, there's nothing there that proves that those are all four equal sides. So it might be very similar to a square, but we call it a rectangle. All right, so here is our next word. Parallelogram, everyone?
Parallelogram.
All right, now I'm thinking that it has a little asterisk here because it is not in your notes, but you're probably going to want to add this because it is pretty important, and that is, this is a figure that has two sets of opposite, congruent, parallel sides. A figure that has two sets of opposite, congruent, parallel sides. So it would look something like that. And ladies and gentlemen, it's very similar to, the formula is very similar to area of a rectangle. It is area equals base times height. All right, and then our last word is trapezoid, everyone? Trapezoid. So you will come across a trapezoid in your homework, and this is a figure that has one set of opposite parallel sides. A figure that has one set of opposite parallel sides. So for example, that would be a trapezoid. The top and bottom are parallel. However, of course, the left and right side are not. So if you write this down, this is very much like an area of a triangle, a formula for area of a triangle. Area of a triangle is 1/2 base times height, or 1/2 height times base. But this one is 1/2 times height times the sum of both bases, which both bases are the parallel sides. So if we come across that in our homework, that's how you solve the area of a trapezoid. Okay, that is it for vocab. So go ahead and grab your book, flip over to page 570. Take out a piece of paper. Name, date, period, assignment number. And let's take a look at some examples. All right, so here's what we're going to do. The very first problem, all I want you to do is I want you to, it's one of those problems I just want you to watch. All right, so take a look at page 570. We're going to take a look at problem number 2. Okay, so I'm going to try the best that I can. Here's number 2. It looks kind of like, I'll go up above here. Oops, sorry. So it looks kind of like this, and then there's some other dimensions to it. So it has this little dotted line with a measurement, little dot here. It's 22 inches. This part from here to here they show is, they label it as 14 inches. Then it has this little thing going down like that and over, and it shows that this is 10 inches. Okay, don't think I'm forgetting anything. All right, so here's what I'm going to do. All right, first off, it's very good to identify what are we dealing with, what kind of figures are we dealing with. Well, I'm dealing with a triangle and a semicircle. All right, so here's what I'm going to do. I'm going to start with probably what I maybe feel is the easiest. Doesn't really matter what we're going to do, but I'm going to start with, I don't know, let's say a triangle. So I'm going to go ahead and find the area of the, and you don't have to write this down, I'm going to find the area of the first figure. I'm going to stop writing steps since you're only watching this time. So the area of this first figure of a triangle is just 1/2 base times height. Now the base to my triangle is the bottom. Basically that would be touching the ground if it was a fancy building. The base is 14. The height, however, is not the side of the triangle. It's from the very top straight down. That's what that is. That's 10. So if I go ahead and solve this, the area is going to equal, well, that's, or I could say 1/2 of 14 is 7. 7 times 10 is 70. So we're talking 70 square inches. And that is what that part is right there. The next part, of course, I'm going to go ahead, I'm going to find the area of the semicircle. So, remember, a regular circle is pi r squared. A semicircle, we're going to split it in half at the end. So, pi is nice because it's always the same, 3.14. This side of the triangle right here is also the diameter of the semicircle. But it's not asking for diameter, it's asking for the radius. So the diameter is 22, the radius is 11. So, here we go. 11 squared I know is 121. Going to bring down the rest. And then what I'm going to then do is grab my calculator. 121 times 3.14 equals 379 and 94 hundredths. And now I'm going to split that in half. So I'll just, in my calculator, divide by 2. And I get 189 and 97 hundredths. And that is in square inches. That's the area of the semicircle. So, 189 and 97 hundredths. Now, we talked about this yesterday when we talked about area of a circle. Is the whole concept of area is basically how many squares fit into the figure. That's what it is. So in this case, these are square inches. 70 square inches in that part, 189.97 in this part. Well, guess what? To find out how many total squares there are, my last step is to take both of these and, oops, and add it up. So I could do that with my calculator. Plus 70 equals 259 and 97 hundredths. If I take a look, let me reread the directions. Round to the nearest tenth. That 7 makes that 9 go up. To a 10, of course, it carries over. So rounding would be 260.0 square inches. Okay. Now, before I answer any questions, let's do another one, and we'll go ahead and actually formally write the steps. All right, but that is how you solve an area of a composite figure. So let's go ahead and let's take a look at the very next problem. All right, so our very next problem, you guys see in your book, I'm going to go ahead and draw this. So 5 centimeters here, 5.7 centimeters there, 2 8/10 centimeters down here, and then they show this, and I'm assuming because of the location of the 3 centimeters, it means just from here to here. Okay. Now, there's an issue with this, and we can call this step star. If there are no clear-cut, if there are no clear-cut composite figures, make them. So here's what I'm going to do. I'm going to take this line right here, and I'm going to make it continue all the way to that line, perpendicular to that line there. What that has just created is that has created a rectangle and a triangle. And there are my shapes. There are my figures. So when I go ahead and complete this, here we go. Step 1. And what I wrote earlier, let's find the area of the first figure. So let's start easy. Let's start with the rectangle. Okay? The area of a rectangle. Now, I kind of explained this to an earlier class, and that is you have to be careful right here, because what students do is they just think that, like, when it comes to formulas, that one size fits all. And here's kind of the analogy I made with my other classes. Okay, those of you that have some at least basic knowledge of how, like, basic tools work, let's say I'm hanging a picture at home, and I have a nail, pretty large nail. Okay, pretty thick nail, but I'm hanging a big picture at my house. So if this is the wall and I am taking that nail and I got to drive it in, I need a tool. I need to go out to the shed to get a tool. First of all, what kind of tool am I going to get? Okay, the tool, that, if you don't know, is called a hammer. All right, you nail nails with a hammer. Talking about a basic nail, I'm going to drive it into the wall with a hammer. Okay, now, if I go to the tool shed to grab a screwdriver, now screwdrivers are good tools. If I'm going to screw into a piece of wood or something, that's fantastic, but that's not the case. I need to drive the nail into the wall. And you do that by striking the nail with the head of the hammer. But if I take the screwdriver and I flip it around and start banging the nail with the end of the screwdriver, it's not going to do anything. If you flip it around and use the plastic handle, if the screwdriver has a plastic handle on it, which a lot of them do, it's going to break the handle. Okay, it's going to crack it. Okay, I need to go out to the shed and grab the correct tool to drive the nail into the wall. Okay, have good tools, but I've got to use the right tool for the job that needs to be done. Now, here's my whole point. when we are grabbing formulas, formulas are tools. They're to help guide you in this case, but they are tools. Now, as we go through this chapter, you will build your shed up with tools. All right? Your shed being your brain, if you didn't understand that part of it, right? So, yes, your brain could be your shed. So we're going to build our brain up with formulas. We've got to have the tools to do it. But here's the main point. Some people don't take this seriously, but if you pull out the wrong tool, you're not going to get the job done correctly. Okay? So you got to pull out the correct tool. So please, don't just, because people take it lightly, you know, they run to the shed and grab the screwdriver when they need a nail. They don't even think about it. Okay? People use the wrong tools. It's not that the other formula is a bad tool, but it is one for this. It's not going to get the job done. So you've got to do, if you grab the wrong tool, you're probably going to get an answer, but it's going to be the wrong one. Okay, so a long story short, even though these two are going to be a little easier when it comes to shapes in this composite figure, we need to grab the right tool. So remember, the very first thing I'm going to do is this rectangle. And a rectangle, or even a parallelogram, we're going to start using base times height. Okay, so to find the area, the base is right here. It's 2.8. I'm going to plug it in, 2.8, 2 8/10. The height of this rectangle, we'll say this is the height, of course, and that is 5 7/10. Now, be careful. Again, be very careful. You need to know what the height is. Some people would just like maybe put the 3 in there, but that's not the height of our rectangle. That's only a little up the side of the rectangle. I got to go all the way up, and that's why I plugged 5 7/10 in. So, to find the area of the rectangle, all I have to do is multiply those two. 2 8/10 times 5 7/10 equals, and I get 15 96/100. Please do not round. Even if the directions say to round, don't round till the end. Remember, the more we round, the less accurate the answer is going to be. Okay? So don't round until the very end if possible. All right, step 2. Here's what I'm going to do. Continue step 1 with all other figures. Now, I say all other figures because sometimes there might be 2 figures, sometimes there might be 3 or 4. This one, of course, only has 2, but that set of directions work on most other problems. So, that is a triangle. Common mistake, people go, that's easy, base times height. And that's what I'm talking about. That is one of the most common mistakes people do. They just think one size fits all. Screwdriver works on everything, all right? That's not the case. Remember, this is a triangle. It's 1/2 base times height. You do all this hard work for nothing if you pull out the wrong tool. It's kind of like some guy hammering in for 2 hours the nail with the end of a screwdriver, right? You do a bunch of hard work, but it's going to take a long time, and I don't know if the job's ever going to get done right. All right, here we go. So, now this particular one I chose to do with you guys because I don't see a height or a base to this triangle. It's not clearly stated, but we do have enough information to find out what it is. Take a look. What I do know about a rectangle is that they are congruent opposite sides, like our vocab said. So this side here would be the same length as this side here. And if this whole thing is 5.7, meaning this whole thing is 5.7, and this part of it is 3, how do we figure out that part? Subtract. So there's going to be some times you need to figure out before plugging those in. I'm going to subtract 5.7 minus 3. Well, what do we get? 2.7. Okay, now I'm going to consider this depending on how you look at this triangle. We'll consider this, even though it's kind of flipped upside down, we'll consider this the height. So I plug in 2 7/10 for the height. If this is the height, that means then that this part right here is the base. We're going to find the base the same way we just did the other. This whole thing is 5. From that point all the way over here is 5 centimeters. But look at, because we drew this perpendicular line here, this part of the rectangle is the same as that. So, what are we going to do again? Subtract. Of course, you take the whole 5 minus that little part there, 2.8, which is really subtracting that part. And I get 2.2. That is the base of our triangle. And here we go. 2.2 times 2.7 equals 5.94. And I'm going to multiply that by 1/2 or divide by 2. And I get 2 and 97 hundredths. Now, when we're all done with all of step 2, with all the figures, there comes step 3, and that is with a figure like this, we're going to add them, right? You have all of those squares in the one, all of those squares in the other. So for note's sake, I'm going to go ahead and rewrite it. 15 and 96 hundredths plus 2 and 97 hundredths. So 2 and 97 hundredths is already in my calculator. Plus 15 and 96 hundredths equals 18 and 93 hundredths. Now, from here, again, right, step star, and that is, remember, sometimes they're going to ask you to round. So if I take a look at the directions on this one, it's the same set of directions, round to the nearest tenth. So the 3 makes the 9 stay the same. So when I round it, it becomes 18 and 9/10. And then, of course, we'll call step 4. And step 4 is put the units on. And so because everything was in centimeters, it is square centimeters. Don't forget the square since we're talking about area. Square centimeters. All right, questions? On one particular problem. Like, for example, like, would this be centimeters and this one be inches? No. I mean, yes, they are going to all be the same. You won't have to convert anything. So if you guys see one, make sure you let me know. But I'm about 99% sure you don't have to convert anything. Okay? I'm going to have you guys try one. Any other questions on the steps, how to go about doing it, or finding missing sides, for example? Okay, here's the one I want you guys to try. Problem number 6. Problem number 6. All right, go. Okay. Anyone need more time? Okay. Checking with you guys in about another 30 seconds or so. Okay, it's still working on that one? Okay, a few more seconds, and then if those of you that are done, by the way, hopefully you're going on and working on some other problems. I'll give you guys a few more seconds, and then we're going to share. Okay. 30 seconds. Go ahead and turn and share. Go.
I got 157.5 meters squared.
Okay, so problem number 6 looked a little like this. It had a bunch of 90-degree angles in it. They're all in meters. Okay, here we go. So the very first thing, right? Find the area of the first figure. Now, there's actually 2 ways you could break this up, right? I mean, there's probably more than that, but in this way, you could split it up here, or you could split it up here. Okay, it doesn't quite matter. All right, I'll break it this way. All right, here we go. Area of the first figure. Let me go ahead and do this rectangle here. So I'm going to go ahead, and that is a rectangle. So base times height. Okay, my base is from here to here. There's no number there. However, it is the same as here to here. And from there to there is 9 plus, of course, another 6. So 9 plus 6 is 15. So my base is 15. My height, however, not this whole thing, it's this side right here, 7 5/10. So if I grab the calculator, 15 times 7 5/10, and I get 112 5/10. Area to the first one. Then the next one. So it's also a rectangle. So it is base times height. Now on this one, if I consider this the base, it's the same as that. It's 6. The height is from here to here. Well, this whole thing is 15. And I do know that that part right there is 7 5/10. So if I take 15 and subtract out the 7 5/10, that should give me this side here. So 15 minus 7 5/10. And of course, that's halfway up, right? 7 5/10 there. So the height is 7 5/10. Okay, so with that said, I go ahead, multiply 7 and 5/10 times 6, and I end up with 45 for our area. And of course, I'm done with all the shapes. I go ahead, add up all of the areas. So 45 plus 112 and 5/10 equals 157 and 5/10. And it is all in meters, so it is square meters. I don't have to round since it's already rounded to the nearest tenth. Okay, questions? Because this, let me see, I'll try to color code it for you. So this whole side here is 15, right? That's what it was labeled. I say, okay, well, if that whole side is 15, I know that this bottom part was a rectangle. So since that is 7.5, so is this bottom part. So what I have is, if I have a line segment, that's kind of what I have here. The whole thing is 15, but from there to there was 7.5. I just subtract the 2, and that will tell me how big that is. Okay, so that's what I did there. All right, guys, other questions? Okay, so I have a little box here. Let's take a look at number 12. We're not going to do it. I do want to give a quick talk about it, just where we know. And most of you guys will be able to figure this out anyway, but I do want to talk about it. So it says number 12 on page 5. It ends up being on 571. It says, refer to the swimming pool shown at the right. And it says, A, what is the area of the pool's floor? All right. So bottom line is, right, composite figure. But then B says a pool cover cost $1.70 per square foot. How much would it cover for the pool cost? How much would it cover for the pool cost? So how would we figure that out? You take the area of the pool, which is the square footage of the pool, and you multiply it by the 1.70, the $1.70. Because for every single one, right, every single square foot, it would be $1.70. So however many square feet it is, you multiply it by $1.70, and you'll get your answer. Okay. Any questions about that? Okay. So area of composite figures.